Hi everyone. In this demo, I'm going to go through the new authentication flow of Spike. So as a quick overview, before this pull request, the admin authentication of Spike was being generated by the admin user creating a token, and that token being validated on Spike Nexus, which is the secret store. And the validation, like, it was working, but the problem with that is the admin token that was generated is a long-living token. So once the token is created, we trust the token like for eternity, and it's not good for a login operation, because in a session authentication you would like to limit the time of the session to a short token, a short time frame, so that if the token is exposed, like the window of opportunity of utilizing the token will be smaller. So if an attacker gets the token, the time that they can use will be limited. So to sort this and to fix that thing, we introduced a new flow. So let me zoom the description a little bit. In a nutshell, what's happening is there's an initialization flow of Spike. So when you first deploy Spike on your machine and you run the Spike init command, the system will create a admin token for you, and the system also will have a root key that is separate from the admin token. Root key is for encrypting all of the secrets, and admin token is to identify and authenticate the administrator. But we wanted to limit the power of this token. So what we are doing is we ask the admin user to also provide a password to associate with that token. And after the initialization, the password is encrypted and stored in the backing store. So when the admin next time enters their password, we'll verify the password, and if the password's hash matches with the hash that we have in the database, we create a short-lived JOT, JSON Web Token, and that JOT is signed by the admin token that we generated before. And the token will be short-living. For the sake of this demo, we are minting a token that lives for 1 day, and it will be configurable. You can make it an hour, 2 hours, 15 minutes, depending on your risk tolerance, essentially. But yeah, so that's the overall flow. The system creates a temporary token and it gives it back to you. So let me quickly try to demo it and see how things go. I will just clear these terminal sections so that I can start from scratch. So I split this pane into 5 parts. Come on, let me change my marker. This top one will be a Spire server that we will be running. The bottom one will be a Spire agent, so that the Nexus and all the other components can talk to and get their SVITs. This is a Spike Keeper, and this will be Spike Nexus, and this will be our Spike CLI. So what will happen is CLI will establish and will send commands to Nexus through RESTful APIs, through MTLS. And these commands are like create secret, get secret, list secrets, those kind of commands. And the Nexus will respond to the CLI if and only if the user has a valid JOT token. So that's how it will work. And we will, by logging in, we'll get the token. We'll see how it works, essentially. So I think showing it is better than explaining. So let me start step by step, and let's see how it works. So I just start the Spire server first by this hack Spire server starter helper script that's in the Spike repo. It will build the binaries and it will start the server. Then I'll do the same for Spire agent. So like here I have a Spire server and a Spire agent running, and they have kind of established a trust relationship between them. Then next up, I'm going to run Keeper and Nexus. So to show it again, this one is Keeper, this one is Nexus. Let me label them. This is text. Just give me a second. I need a different color. Maybe green. This is... I wanted green, come on. This is Spike Keeper. This one is Spike Nexus. And Spike Keeper and Spike Nexus fetch their SWITs from the Spire agent. So both of them have certificates. And this way, Nexus can talk to the CLI, and Keeper and Nexus can talk to each other using MTLS. Let me write MTLS down here. This connection is MTLS. This connection is also MTLS. They can establish this connectivity by the SWITs that have been dispatched. This is an SWIT. This is also an SWIT that have been given by Spire agent to them. And this one is Spire server for the sake of completeness. So Spire server like fetches some trust material, and then it distributes those trust material to Spike Keeper and Spike Nexus. So that's that's what's happening behind the scenes. So if I do a Spike command, it will just show a help message, and it will, oh come on, it will say like these are the commands that you can do. But if I do, for example, like a Spike get I don't know, tenants acme db, it will say it's not initialized, please run Spike init. If I run Spike init, now it will say, hey, I need your password because I'm going to create a token and associate that token with your password, and that will be your root token. By the way, the root token will be stored on Nexus. It won't be given to the admin, and that root token will be for auditability and also for encryption purposes. Essentially, I'm just pasting my password here. I don't want to like manually type it, and ideally you should be keeping that password in a password manager instead of punching it yourself, and that password should be like secure. The more random, the more entropy in your password, the better, of course. So I entered my admin password. I'll paste it again for confirmation. And it says, yay, the Spike system has been initialized. You can use Spike login to authenticate. So let's do a Spike login. It will ask for my password. I'll enter my password again, enter, and my login is successful. So what happened behind the scenes is, while I logged in, I got a admin token. It's a short-lived token that I can use to identify myself. So any other API request that I do won't need me to enter this password. I can use this token for as long as it is valid, essentially. Let's see what that token looks like. Clear cat spike Spike admin token. It's a JSON web token, and as in any JOT, we can like see what it has. Okay, so I pasted the token and I can see the details about the token essentially. The algorithm, the details of the token, its expiration date, and other stuff. The token belongs to Spike admin, and the token is issued by Nexus, which is um, our secret store essentially. And there is also like this bit that you can use to verify the signature as long as you have the secret key, which you don't, so you cannot be able to verify it, but it's not for the user to verify anyway. The server is supposed to verify the token, but that's the token that we have. So since we have the token, now the system will use it. And if I use the same command, spike get tenants acme.db, now it will say secret not found. If I do spike put tenants acme.db username root pass spike rocks, enter, now I have registered the secret. And if I do a spike get tenants acme.db, I will see the password and username down here, and you can see like there is this messages like being exchanged. Like let me move it upwards so it doesn't scroll. So this is like valid token somewhere here. It says, it created the secret. Other than that, like it's doing some validity checks. It's not, if the token was invalid, then I won't be able to like get what I want to get essentially. And it's easy to emulate that. So let's see. Vim spike admin token. If I change the token, like if I add, for example, like I don't know, a digit 1 here, now I have a invalid JSON web token. So I can try to run the same commands by get tenants acme.db, and it will say, hey, I have an error in this JSON output, which is happening because the token is invalid. The thing is, like, we should return a more friendly error response to the user, but that's upcoming. The code is like in a mergeable state at the very least, and I'm going to add additional pull requests to rectify some of these error messages. Let me like edit the token again, remove that digit that I inserted, and if I run spike get tenants acme.db, I'll see my response as expected. So that was a quick demo about the login and authentication flow of Spike. Like I said, this is work in progress. There are still rough edges, but yeah, we have a JOT compatible token-based authentication for Spike, and this opens a really nice avenue for exploration because JOT is a standard format, so you can use anything that understands JOTs. For example, later down the line, we can integrate Spike with an identity server like Keycloak, or we can use some OIDC federation and use different kinds of JOTs and kind of mingle them. Or, for example, we can leverage the tokens that other services create and things like that. But as far as this demo goes, that's all I have. Hope you liked it. Yeah, Spike is a really nice project. It's at its early inception, early infancy, and more features we are adding to it. We have started getting contributions from the community as well. I want to say hello to Shahin, our first volunteer contributor from the community. I'm sure more will come, and it will be awesome. Expect us and wait more from us. And until next time, keep your secrets secret.